Welcome back, my dear students. Today in this session we will learn about a new functions, that is velocity potential function and stream function. Your velocity potential function is defined as the scalar function of space and time such that its negative derivative with respect to any direction gives the fluid velocity in that direction. So it is defined as phi. Okay, so your velocity potential function is a type of function, okay, and it is a scalar function of space and time. It depends upon the space and also with time, and its negative derivative velocity function andre is a term whose negative derivative with respect to any direction, means with respect to x direction, y direction, z direction, okay, gives the fluid velocity in that direction. So what we know, u is a function of x, okay, u is the function of, means u is the fluid velocity in x direction, v is the fluid velocity in y direction, w is the fluid velocity in z direction, right? So its negative derivative means the velocity potential is defined as what? Phi. If we take, see here, dou pi by dou x and its negative derivative of dou phi by dou x, if we do, we will get directly the value of u. If dou phi by dou y, we'll get the negative derivative of dou phi by dou y is v. The negative derivative of dou phi by dou z is w. So directly we will get the values of u, v, w. Just we have to do differentiate partially with respect to phi. Okay, not with respect to phi, with respect to direction, but we have to differentiate what? The velocity potential function phi. Okay, remember this formula. So what is, according to the velocity potential function, what is u? U is defined as negative derivative of d phi by dx. So you have to remember, okay, v minus dou phi by dou y, w is equal to minus dou phi by dou z, like this. Okay, u1 raised to v w. Okay, so now these are standard terms for that whenever we talk in consideration with the velocity potential. Okay, now we will substitute this equation in our continuity equation. Okay, so see, the continuity equation for an incompressible steady flow is what? Dou u by dou x, dou v by dou y, and dou w by dou z is equal to 0. So this is the continuity equation for incompressible steady flow in 3D direction. Okay, but what the velocity potential function value gives us, that is u is equal to minus dou phi by dou x, v is equal to minus dou phi by dou y, w is equal to minus dou phi by dou z, right? So we will substitute this value of u, v, w in the continuity equation. See, what is the continuity? Okay, value of u is what? Dou phi by dou x, v dou phi by dou y, and z dou phi by dou z, right? U, v and w, we just substituted the value of u, v and w according to the velocity potential function. Okay, once we substitute and we simplify, what are we getting? We get a famous equation in your mathematics, that is dou square phi by dou x square, dou square phi by dou y square, dou square phi by dou z square. What is that? It is the famous Laplace equation. Here it is there. It is the Laplace equation. So for two-dimensional case, this equation reduces to one of the item we will make as 0 if two-dimensional case is there. That is dou square phi by dou x square, dou square phi by dou y square is equal to 0. If suppose for three dimension, this formula only, dou square phi by dou x square, dou square phi by dou y square, dou square phi by dou z square. So it is your Laplace equation. So what we can conclude, that if any of value of phi, if the value of phi satisfies this equation, if this satisfies the Laplace equation, will corresponding to some case of fluid flow. Okay, it will correspond to some case of fluid flow. So what is that case? We will see in future coming slides. Okay, understood? So according to the velocity potential function, some values of u is there, that is minus dou phi by dou x. So phi is what? Velocity potential function. So negative derivative of phi with respect to the ಡೈರೆಕ್ಷನ್. ಇಫ್ ಎಕ್ಸ್ ಇದ್ರೆ ಯು ವ್ಯಾಲ್ಯೂ ಕೊಡುತ್ತೆ, ವೈ ಇದ್ರೆ ವಿ ವ್ಯಾಲ್ಯೂ ಕೊಡುತ್ತೆ, ಝಡ್ ಇದ್ರೆ ಡಬ್ಲ್ಯೂ ವ್ಯಾಲ್ಯೂ ಕೊಡುತ್ತೆ. ಬಟ್ ವಿ ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ಇಟ್ ಈಸ್ ಅ ನೆಗೆಟಿವ್ ಡಿರೈವೇಟಿವ್. ಓಕೆ, ಸೊ ಅದನ್ನ ಎಲ್ಲಿ ಹಾಕಬೇಕು? ಇನ್ಕಂಪ್ರೆಸಿಬಲ್ ಫ್ಲೂಯಿಡ್ ಕಂಟಿನ್ಯೂಟಿ ಇಕ್ವೇಶನ್ ಫಾರ್ ಇನ್ಕಂಪ್ರೆಸಿಬಲ್ ಫ್ಲೂಯಿಡ್ ಇದೆಲ್ಲ ಆ ಇಕ್ವೇಶನ್ ಅಲ್ಲಿ ಹಾಕಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಲ್ಯಾಪ್ಲೇಸ್ ಇಕ್ವೇಶನ್ ಸಿಗುತ್ತೆ. ಅದರಿಂದ ನಾವು ಏನ್ ಇನ್ಫರೆನ್ಸ್ ಕೊಡಬಹುದು? ಲ್ಯಾಪ್ಲೇಸ್ ಇಕ್ವೇಶನ್ ಇಫ್ ಫೈ ಸ್ಯಾಟಿಸ್ಫೈಸ್ ದಿಸ್ ಇಕ್ವೇಶನ್, ಎಲ್ಲಾ ವ್ಯಾಲ್ಯೂಸ್ ಹಾಕಿ ನಮಗೆ ಈಕ್ವಲ್ ಟು 0 ಅಂತ ಬಂತಂದ್ರೆ, LHS ಈಕ್ವಲ್ ಟು RHS ಆತಂದ್ರೆ, that will conclude to some case of fluid flow that we will learn later. This was about the u directions. Okay, UVW. Okay, now if the function is a polar coordinate, then the rotational components are given by, so in the Cartesian coordinates it was given by what? U, V, W, right? In the Cartesian coordinate. If it is in polar coordinate, we will have omega x, omega y and omega z. Okay, the velocity potential function is what? Half into dou v by dou x minus dou u by dou y. See, omega y is equal to half into dou u by dou z minus dou w by dou x. Omega x equal to half into dou w by dou y minus dou v by dou z. So these are the values of omega x, omega y, omega z if the function is for polar coordinate, that is rotational components, rotation along its own components. So rotational components kotre you have to use these values. Henge formula ಬರೆಯೋದು? So omega x ಅಂತ ತಗೊಂಡ್ರೆ, so half into dou w by dou y, so dou w by dou y, dou v by dou z. So it's a cyclic. Okay, if you remember one, it's enough. Okay, if you remember one term, it's enough. See here, omega z is equal to half into dou v by dou x minus dou u by dou w, dou y. Correct? Now how to write dou y? So z, x, y, z is cycle. Okay, x admele y, y admele z. Okay, now after u, v will come, after v, w will come, after z again x we have to take, after w again u have to take. So you remember one. Okay, for example we will start with x only. Omega x is equal to what? Half into dou w by dou y minus dou v by dou z. Then omega y, x is the ಜಾಗದಲ್ಲಿ y ಹಾಕಿ, half into u ಇದ್ದ ಜಾಗದಲ್ಲಿ ಏನು ಹಾಕಬೇಕು? ಅಲ್ಲ ಸಾರಿ, w ಇದ್ದ ಜಾಗದಲ್ಲಿ ಏನು ಹಾಕಬೇಕು? w. ನೆಕ್ಸ್ಟ್ ಯಾವ ಸೈಕಲ್ ಬರುತ್ತೆ? u. y ಇದ್ದ ಜಾಗದಲ್ಲಿ z ಮೈನಸ್ v ಇದ್ದ ಜಾಗದಲ್ಲಿ ಏನು ಹಾಕಬೇಕು? w. z ಇದ್ದ ಜಾಗದಲ್ಲಿ x. So it is just cyclic. If you remember one, you can write for omega y. Okay, if you remember omega y, just u ಇದ್ದಲ್ಲಿ v ಹಾಕಿ, z ಇದ್ದಲ್ಲಿ x ಹಾಕಿ, w ಇದ್ದಲ್ಲಿ u ಹಾಕಿ, x ಇದ್ದಲ್ಲಿ y ಹಾಕಿ. You can write all the three terms of omega x, omega y, omega z. Okay, so these are what the properties of potential function for rotational components. Okay, for rotational components, these are the potential functions. Okay, so once we got the rotational components, then we have to substitute. So omega z, half into dou by dou x of, we have to substitute the value of, so what is omega z? That is v. Okay, u term we already know what is u and v. Here the value of, wait, see the value of u, note it down. So u is equal to minus dou phi by dou x minus dou phi by dou y, dou phi by dou z. So these value we have to substitute in the equation for rotational components. So v value, u value, u value, w value, dou w, dou v. So once we substitute the values, it's a lengthy process. Okay, it's given directly here. So half into, when we simplify, what we will get? Dou square phi by dou x into dou y plus dou square phi by dou y into dou x. It is omega z. Omega y is equal to half into minus dou square phi by dou z dou x plus dou square phi by dou x into dou z. So similarly, omega x equal to half into minus dou square phi by dou y dou z plus dou square phi by dou z dou y. So these are the values, final values we are getting for omega z, omega y and omega x. So what if ಇದನ್ನ ತಗೊಂಡು ಏನು ಮಾಡ್ಬೇಕು ನಾವು? If phi is a continuous function, if phi is a continuous function, then these all are equal. Okay, hence if phi is a continuous function, dou square phi by dou x dou y, dou square phi by dou y dou z. Okay, if it's a continuous function, then it will be equal. No, then omega z, omega y, omega x equal to 0. So the rotational will be 0. When the rotational components are 0, that flow will not rotate. It is irrotational. Hence the properties of functions are, if the velocity function phi exists, okay, if the potential velocity phi exists, the flow should be irrotational. Okay, ಇದರಿಂದ ಏನು ಹೇಳ್ಬೋದು? So these are important, these inferences are important. If the velocity potential function phi idre, if it has a value, then the flow should be irrotational. If the velocity potential phi satisfies the Laplace equation, it represents the possible steady incompressible irrotational flow. Okay, if phi satisfies the Laplace equation, it is a steady, incompressible and irrotational flow. Understood? Okay, so this is like problem, like okay, we have to do by handwriting, but okay, no problem. So if velocity potential phi, if it is exists, if it has some value, then the flow is irrotational. If it also satisfies the Laplace equation, then it is a steady, incompressible and irrotational flow. So by just adding the value of phi in the continuity equation, we can tell the type of flow it is. Okay, if it is satisfies, we can directly tell it is a steady, incompressible, irrotational flow. So that is the main intention why these potentials are introduced. Okay, so this is velocity potential. Next we will go to the one of the problem. See, it's direct question will be there. Just you have to derive the partial differentiation is coming in the picture, and we have answers. So whatever the question maybe from this velocity potential, it will be very easy. Okay, see, directly they give the value of phi. So phi is equal to what? Phi into x square minus y square. Calculate the velocity components at points 4 and 5. So 4 is x value, y is phi value. So directly what you have to do? Dou phi by dou x, it is 10x. So phi we have to differentiate with respect to x and also with respect to y. Hence it is only x and y we can take in only 2D direction, that is dou phi by dou z is 0. Okay, so dou phi by dou x is 10x, dou phi by dou y is minus 10x if we differentiate. So but velocity components u and v are given by equations which we just now saw. No, u is equal to what? Negative derivative of dou phi by dou x is minus 10x. Directly they are given the value of phi, they will ask you to find the value of u in the competitive exams. Directly use this equation, negative derivative of dou phi by dou x. They will give the value of phi, and also they can tell you to find the value of v in, or they will tell to find the velocity in y direction. Then you have to find this value, velocity in horizontal direction, you have to find u value. Okay, that is negative derivative of with respect to y, that is 10y. Okay, now 10x, yeah, what is the value of x? 4, it is 40 units. X value is 4, y is 5, 10 into 5 is 50 units. So very easy, just we have to remember what? U is equal to what? V is equal to what? When it comes to the velocity potential function, so u is a negative derivative of dou phi by dou x, v is a negative derivative of dou phi by dou y. Okay, in competitive exam they will just give the value of this, and they will tell to find the value of u and v, like that, for 1 marks. Now we'll go for the stream function. So stream function as velocity function only, but it is a stream function. So same, it has some values, we have to just substitute in the continuity equation. So it is defined as a scalar function. It is a velocity potential also scalar function. It is also scalar function of space and time, such that it is a partial derivative with respect to any direction. With respect to any direction, gives the velocity components at right angles to that direction. It is denoted by psi and defined only for two-dimensional flow. Okay, mathematically for steady flow it is defined as phi is a function of x comma y. So velocity potential it is also a function, it is also a scalar function of space and time such that its partial derivative, its negative partial derivative with respect to any direction gives the value of the velocity potential function. But ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, it is negative positive ಅನ್ನೋದೇನಿಲ್ಲ, this is directly positive value ನೇ. But here if you derive, means if your derivative is with respect to x, psi is a function of stream function. If your stream function is derived with x, you will not get the value of u, but you will get the value of v. This is the major difference. So dou psi by dou y minus u. Okay, so u and v are mutually perpendicular and it's only for two-dimensional flow. So that is the major difference you have to note down. What is dou psi by dou x gives the value of v and dou psi by dou y gives the value of u. But here when you take partial differentiation of y, you will get a negative value for x, that is minus u. The velocity components in cylindrical polar coordinates, if it is a polar coordinate, so ur is equal to 1 by r into dou psi by dou theta, u theta is equal to minus dou phi by dou r. So ur is the radial velocity, u theta is the tangential velocity. So directly remember these values, okay, for polar and this is for Cartesian coordinate. Okay, what is the major difference? Its derivative in the particular direction gives the velocity of its next, means dou phi by dou x ಮಾಡಿದ್ರೆ ನಿಮಗೆ v value ಸಿಗುತ್ತೆ, dou phi by dou y ಮಾಡಿದ್ರೆ u value ಸಿಗುತ್ತೆ, but u has a negative effect. This is about the stream function. The continuity equation in okay, this continuity equation for two-dimensional flow is dou u by dou x plus dou v by dou y. Now what we have to do, we have to substitute the value of u and v. What is u? This one. What is v? This one. We have to substitute in the continuity equation. So once we substitute and simplify, we are getting that, so see here, dou partial derivative with respect to x, so this is what dou phi by dou y, the value of u, this is the value of v. So once we calculate and once we simplify, we will get the value of this one. You have to know, you have to derive it, okay, in your notes you have to derive it. Dou square phi by dou x into dou y plus dou square phi by dou x into dou y is equal to 0. Hence existing of psi, if the psi means a possible case of fluid flow, the flow may be rotational or irrotational. Okay, if the phi satisfies this equation, it will give us some possible case the flow may be rotational or irrotational. How to know it is rotational or irrotational? We have to use another term, omega, wz. It's w, not it is omega. Okay, so omega z is given by what? Half into dou v by dou x minus dou u by dou y. You already explained here. Okay, so substituting the values of u and v from the equation. So u and v already know. Once we substitute, we will get the equation dou square phi by dou x square, this half into dou square phi by dou x square into plus dou square phi by dou y square. We will get this equation. But for steady flow, for irrotational flow, part of omega value should be 0. So once it is 0, the above equation will become dou square phi by dou x square plus dou square phi by dou y square. So this is the equation to be remembered. If the psi value, so it is what? Your famous Laplace equation. So this function only changes. Psi alli phi change agittu, illi psi change agta ide. Okay, so the properties of stream function psi are, the stream function psi exists adenadru idre, it is a possible case of fluid flow which may be rotational or irrotational, same as velocity function. If the phi exists, means it may be rotational. Okay, what I told, if phi exists, the flow should be irrotational. Here, if psi exists, this is psi, okay, this is psi, psi. If psi exists, it is a possible case of fluid flow which may be rotational or irrotational. It will not give a clear picture that is rotational or irrotational. It will give a doubt only. Okay. If stream function psi satisfies the Laplace equation, it is a possible case of irrotational flow. It is a possible case of irrotational flow. But velocity potential on the other hand, if phi exists andre the flow should be irrotational. If phi satisfies Laplace equation anta helidre, it represents the possible stable incompressible irrotational flow and directly adu the velocity potential will tell us that it is a possible case of that. If psi satisfies the Laplace equation, it tells the possible case of irrotational flow. Okay, basically the psi and phi, okay, if they exist means it is rotational. Okay, if it exists means in velocity potential function, if it exists means it is irrotational. Here in stream function it may be rotational or irrotational, so the stream function gives a doubt in that. It may be, it is telling it may be, but velocity function alli ಏನು ಹೇಳ್ತಾರೆ ಅದಿದ್ರೆ ಅದು irrotational ಅಂತಾನೆ ಹೇಳ್ತಾರೆ. So this is about the stream function. So velocity potential function and stream function. Next we will see the relation between stream function and velocity function. Okay, so we have u is equal to minus dou phi by dou x and v is equal to minus dou phi by dou y, right? From equation 5.12 means these are the equations which we already dealt in our previous slides. Okay, with respect to phi, what is the value? So it is both are negative value, right? And with respect to psi, so this is what velocity potential function. 1 minute. Okay, so this is what velocity potential function and this is what your stream function. What is stream function? So u is negative derivative of dou psi by dou y, v is dou psi by dou x. Now what we can do, we will compare it. Okay, so thus u is equal to minus dou phi by dou x, which is also equal to minus dou psi by dou y, and v is equal to dou phi by dou y, that is negative, and is also equal to dou psi by dou x. So this is also equal to u and this is also equal to u, then this is equal to this. Okay, so this is also equal to v, this is also equal to v, then these both are equal to each other. Fine, so that is only they are written. So hence dou phi by dou x is equal to dou psi by dou y, this negative will cancel, and dou phi by dou y is equal to dou psi by dou x. So this is what the relation between the stream function and velocity function, which you have to remember. This is the formula: dou phi by dou x is equal to dou psi by dou y. Just you have to change the see here. Whenever the velocity function comes with the stream function x and y, so dou phi by dou x equal to dou psi by dou y. Okay, no confusion here. Whenever you come with y function, then your psi function will be what? X, and it will be negative. Just remember this formula. Okay, now we got to know the relation between stream function and velocity function. Next we will see one of the question. So a stream function is given by psi is equal to 5x minus 6y. Calculate the velocity components and also magnitude and direction of resultant velocity at any point. Okay, they have given the stream function. So this is the stream function. So what we have to do, we have to differentiate with respect to x and y. So with respect to x ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, dou phi by dou x is 5, dou phi by dou y is minus 6. But the velocity components u and v in terms of stream function, whenever you do a problem with stream function, we have to use the formula for stream function only. So what is u? U is a negative derivative of dou phi by dou y, so it's minus 6 units per second. V is a dou phi by dou x, so 5 units per second. Direct formula substitution, that's it. So resultant velocity square root of u square plus v square. that is 7.81 unit per second. So whenever you want direction, that is V by U, tan theta is equal to V by U 0.833. So theta is equal to 39 degree 48 minute. What they have given? Phi is given. Okay, 5x minus 6y. So whenever any stream function is given, we have to differentiate with respect to x or y. We will get a value. Okay, once we get the value, we have to take the respective formulas with respect to the function. Stream function formula is this and v is this. Just add the values here, you will get a value. Resultant velocity ಕೇಳಿದ್ರೆ just square root of u square plus v square. Okay, if they give the direction, then theta is equal to tan inverse of v by u. Will get the value of 39 degree 48 minute. So this is what stream function, velocity function, and the relation between the stream and velocity potential function. Fine. So just remember the formulas and 2 lines about them. That's enough for the VTU exams. Okay. Now you will see the another concept, that is equipotential line. As the name suggests, equipotential, the potential should be equal. Whenever the potential head are equal, so whenever the potential heads are equal, if we take a line on that heads, then it is called as a equipotential line. A line along which the velocity potential phi is constant is called as equipotential line. So this you'll get to know further. Okay, for just now you have to take down that a line along which the velocity potential is constant. Velocity potential phi constant idre ಆ ಲೈನ್ ಅನ್ನು ನಾವೇನು ಕರಿತೀವಿ, equipotential line ಅಂತೀವಿ. So if phi is constant, okay, the dou xi will be, the change in the stream function will be 0. So phi is a what? Function of x and y for steady flow. Okay, so change in the d phi is equal to what? Dou phi by dou x into dx plus dou phi by dou y into dy. Okay, what is dou phi by dou x? Minus u. What is dou phi by dou y? Minus v. Substitute it, you will get directly dou phi is equal to u dx plus v dy. Okay, so this is about the formula for this, that's it, d phi value. But for equipotential, what? This d phi is only equal to 0. So whenever the d phi is equal to 0, okay, then what happens? This equation reduces to dy by dx is equal to minus u by v. Okay, dy by dx is nothing but what? Slope of equipotential line. Okay, just don't worry, it's an introduction for you. Okay, what is equipotential line and its some derivatives. Okay, don't just remember this formula, try to remember this formula. Okay, slope of equipotential line is what? Dy by dx. So whenever the velocity potential phi is constant, you will get the slope for equipotential line. Okay, whenever the line of stream constant, whenever phi is constant, you will get this equipotential line. What about if xi is constant? Okay, we will see in the next slide. Okay, so for equipotential line, d phi is equal to 0, you will get dy by dx as minus u by v, and this dy by dx is called as what? Slope of equipotential lines. Remember this, dy by dx is minus u by v. Now, so line of constant of stream function. If the stream function is constant, then the d phi value is equal to 0, right? Then d psi is equal to dou psi by dou x into dx, dou psi by dou y into dy. That is nothing but the value of same. D psi by dx is v, d psi by dy is minus u. So substitute it, you will get dy by dx as v by u. Okay, and dy by dx is a slope for streamline. Okay, so what you have to remember here is, whenever you take xi as constant, the slope for the streamline you will get as V by U. Okay, whereas the slope when you take an equipotential line you will get U by V. Okay, equipotential line the slope is negative of U by V. Stream function if it is constant you will get a slope of dy by dx. So from this both equation, okay, it is clear that, so this is A and this is B, it is clear that the product of the slope of equipotential line and the slope of streamline at a point of intersection is equal to -1. If we multiply the slope of stream function into the slope of equipotential line or the slope of the velocity potential function, then what we will get? We will get a value of -1. Thus, the equipotential lines are orthogonal to streamline at all the points of intersection. ಇಲ್ಲಿ remember ಇಟ್ಕೋಬೇಕಾದ point ಯಾವುದು? The equipotential lines are orthogonal, are perpendicular to the streamlines at all the point of intersection. Where you will get to know this? So this is you will get to know clearly when you in the coming classes. Okay, what is this streamlines, where we use that, what is the necessary to study this all, you will get to know in coming classes. Just remember the formula and what is the concept. If the slope of the equipotential line and also the streamlines are orthogonal to each other, means the equipotential line perpendicular ಆಗಿರುತ್ತೆ streamline ಗೆ, streamline equipotential line ಗೆ perpendicular ಆಗಿ ಇರುತ್ತೆ. Okay, so now next concept is our flow net. So what is a flow net? A flow net consists of two groups, flow lines. Okay, the flow lines represent the path that a particle of water takes as it travels through the soil mass. So see here, this is the soil mass, this is the total head. So equipotential line ಅಂದ್ರೆ ಏನು? Velocity potential head is equal to 0. So these are nothing but what? Equipotential lines. And these flow lines are what? Stream lines. ಈಗ ಓದಿದ್ರಲ್ವಾ stream lines. So ಇದನ್ನೇ ಅವ್ರು ಹೇಳಬೇಕಾಗಿರೋದು, because to introduce the concept of flow net. So about this flow net you will study in your 4th semester hydrology clearly. Okay, a flow net ಅಂದ್ರೇನು? It consists of two group of curves. ಒಂದು ಗ್ರೂಪ್ ಯಾವುದು? ಫ್ಲೋ ಲೈನ್ಸ್, ಇನ್ನೊಂದು equipotential line. So flow lines ಅಂದ್ರೆ ಯಾವುದು? Stream lines. Okay, represent the path that a particle of water takes as it travels through the soil mass. So ಒಂದು ವಾಟರ್ ಡ್ರಾಪ್ಲೆಟ್ ಸಾಯಿಲ್ ಮಣ್ಣಿನ ಒಳಗಡೆ ಹೇಗೆ ಮೂವ್ ಆಗುತ್ತೆ, okay, it will be represented by flow lines. How a water takes as it travels through the soil mass. So what are equipotential lines? Equipotential lines are the lines that pass through the points of equal head. Okay, if this is the soil, so see here, so this gray color is soil, consider. Okay, this green color are flow lines. Okay, if flow lines green color do, so the what about the head? Here at the cross section head, the heads will be same. Okay, same head alli. Okay, here they are mentioned no x y z. So at x y z the heads are same, that is h is equal to 0.5 h. The pressure are same. ಸೊ ಒಂದೇ ಪ್ರೆಷರ್ ಇರೋ ಕಡೆ ನಾವೇನಾದ್ರೂ ಒಂದು ಲೈನ್ ತಗೊಂಡು ಅಂತ ಹೇಳಿದ್ರೆ ಆ ಲೈನ್ ಅನ್ನು ನಾವು ಈಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಲೈನ್ ಅಂತೀವಿ. ಇದೇನು? ಈಕ್ವಲ್ ಪೊಟೆನ್ಷಿಯಲ್, ಈಕ್ವಲ್ ಹೆಡ್. ಸೊ ದಟ್ ಪಾಯಿಂಟ್ ಇಂದ ನಾವೇನಾದ್ರೂ ಗೆರೆ ಹೇಳಿದ್ರೆ, ಸೊ ದಟ್ ಲೈನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ equipotential line. As I already told you in the last slide, what is that? These equipotential line and the streamline are perpendicular to each other. Okay, whenever a water moves inside the soil and these flow lines are parallel to each other, for these flow lines equipotential lines will be perpendicular to the it. Okay, it will be perpendicular to it. So this is about the flow net. So a grid obtained by drawing a series of, so grid form ಆಗಿದೆಯಾ? A grid obtained by drawing a series of equipotential line and stream lines is called as flow net. So a flow net is an important tool in analyzing two-dimensional irrotational flow problems. If two-dimensional irrotational flow ಏನಾದರೂ ಬಂದ್ರೆ, so for that type of problem you will require a flow net, which you will study in detail in your next semester. Okay, so flow lines and equipotential lines. Next, so flow lines represent the path that a particle of water takes as it travels through the soil mass. So here the flow lines are what? It represents the path that ಒಂದು water droplet soil ಒಳಗಡೆ ಹೇಗೆ ಮೂವ್ ಆಗುತ್ತೆ. So the path taken by the water to move into the soil is given by what? Flow lines. The space between two adjacent flow lines is called as flow path. Discharge through each flow path is equal. So if it's equal means it's parallel only, right? So next, so equipotential lines. These equipotential lines are lines that pass through points of equal head. So the space between two adjacent equipotential lines represents a drop in head. Okay, the space between two adjacent equipotential lines represents drop in head. The space between two adjacent equipotential lines is called as an equipotential space. Okay, so two adjacent equipotential line ಮಧ್ಯ ಏನಾದರೂ ಹೆಡ್ ಇದ್ರೆ ಅದರ ಡ್ರಾಪ್ ಇನ್ ಹೆಡ್ ಅಂತ ಹೇಳ್ತೀವಿ ಒಂದು ಇದು ಮಾಡಿದಾಗ. ಸೊ ದ ಸ್ಪೇಸ್ ಗೆ ಏನಂತೀವಿ? ದ ಸ್ಪೇಸ್ ಬಿಟ್ವೀನ್ ಟು ಅಡ್ಜಸೆಂಟ್ ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಲೈನ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅನ್ ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಸ್ಪೇಸ್. ವ್ಯಾಲ್ಯೂಸ್ ನ ಡ್ರಾಪ್ ಅಂತೀವಿ, ಬಟ್ ಸ್ಪೇಸ್ ನ ಇಕ್ವಿಪೊಟೆನ್ಷಿಯಲ್ ಸ್ಪೇಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೆಕ್ಸ್ಟ್, an equipotential line means potential head at all the points is equal. So this one I am telling. Okay, potential head at all the points is equal. So ಆ ಪಾಯಿಂಟ್ ಗಳಿಂದ ಮಾತ್ರ ಬರ್ದಿರೋ ಲೈನ್ ಅನ್ನು ನಾವು equipotential line ಅಂತೀವಿ. So water in a piezometer. So piezometer is the device to measure pressure. So water in a piezometer placed at different points along an equipotential line will rise in the same elevation. So equipotential line ಎಲ್ಲಿ ಮಾರ್ಕ್ ಮಾಡಿರ್ತೀವಲ್ಲ ಅಲ್ಲೆಲ್ಲ ನಾವು ಪೀಸೋಮೀಟರ್ ಇಟ್ಟರೆ, ಸೊ ಆ ಪೀಸೋಮೀಟರ್ ಅಲ್ಲಿ ಸೇಮ್ ಲೆವೆಲ್ ಆಫ್ ಹೆಡ್ ತೋರಿಸುತ್ತೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಅಂಡ್ ಇಟ್ಸ್ ಟ್ರೂ. ಓಕೆ, ನಾವು ಹೌ ಟು ಡ್ರಾ ಅ ಫ್ಲೋ ನೆಟ್. This is not important. This is not in your syllabus drawing at all. Just you have to know what is flow net. Flow net, a grid obtained by drawing. See the grid. You are seeing a grid. So water flow net anta kelbodu ashte. You don't have this much of syllabus. You could have been asked for the definition of flow net. That's it. Okay. What is the flow net? A flow net is a grid obtained by drawing a series of equipotential lines and stream lines or flow lines ಅಂತ ಕರಿತೀವಿ, is called a flow net. A grid obtained by drawing series of equipotential line and flow lines is called as a flow net. Okay, the flow net is an important tool in analyzing 2D irrotational flow problems. You have to remember these 2 points only. And the flow lines and equipotential lines are right angles to one another. The flow lines are parallel to no flow boundaries. Equipotential lines are parallel to permeable boundaries. Discharge through each flow path is equal. Okay, head loss through each equipotential space is equal. So whatever head loss, each potential space is equal. So when you go through in detail from basics, no, from then you will get understand. Just they have introduced the concept of flow net in your syllabus. That's it. It will come in hydrology. Okay, so this was about the module 2 kinematics of fluid flow. Thank you. I hope you have understood. Please write and again you learn so that you will be comfortable, as it is a new concept to you. Thank you. Good day.